Hey everybody, it's Mrs. Hofferberth. Let's talk about the words and the vocabulary of the periodic table. As you look at the periodic table, it's arranged in rows and columns, and we have words for that. The rows of the periodic table, those are called our periods. That's where the period of the periodic table comes in. So every horizontal row is a period. And we number those periods from top to bottom. So we have period 1 at the top, period 2 is the second row, period 3, 4, 5, 6, and 7. So those horizontal rows are your periods. And on the periodic table that you guys have, which is the one I have on this screen, this is the Web Elements most current periodic table. You'll notice at the bottom that there are 2 rows. These rows actually belong right here in the middle. That's why there's a star and a double star there, because those elements would actually slide right in to make a much wider periodic table that doesn't fit very well on a piece of paper. But if you go to ptable.com, one of your options at the top here is to show the periodic table wide. This is truly in the way the elements are organized. We're going to be talking a lot more about that. But let me show you what that would look like. So it's going to cycle itself back in. It's putting those elements in the middle. Ooh. And you'll see that that's what the periodic table really looks like. So there are 7 horizontal rows or 7 periods to the periodic table. And the block at the bottom is part of those 7 periods. Now again, normally we drop them out just because it fits better. And so we have the normal way you would see the periodic table. Okay, so the rows of the periodic table, those are called the periods. The vertical columns on the periodic table, those are called our groups or our families. Those 2 words are used interchangeably. As you look at the periodic table, there are a total of 18 columns that fit in the standard periodic table where we're not looking at it wide. And each of these we call by number. So we've got group 1, group 2 is the second column, group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, 11, 12, and then we have group 13, 14, 15, 16. And you'll see that the numbers are actually up here at the top of the periodic table for those different groups. So we have periods running horizontally and groups or families running vertically. Those are our first words. Now the periodic table was originally organized by arranging elements based on both increasing mass but also based on their chemical and physical properties. And so when we look at the periodic table and the way it's organized, there's some patterns that allow us to group our elements together. And it's super handy to be able to talk about elements as a group rather than having to talk about each individual one. So make sure you grab your periodic table because we're going to start doing some annotation. We're going to do some labeling of some important pieces of the periodic table. Okay, so when you look at the elements, all of the elements on the kind of the left side of the periodic table, things like lithium, magnesium, sodium, iron, copper, these are all metals. So the left side of the periodic table is metals. Well, where does it kind of break? Like, where does the left side start? There is a zigzag line that I want you to draw on your periodic table. It starts between boron and aluminum, and then it steps its way down the periodic table, kind of like a nice little stair step. And this is going to be our dividing line between metals and things that aren't metals, so our non-metals. Let's do some additional labeling here. Okay, so all this stuff over here, we're going to leave hydrogen out because it's special. But all of these fabulous elements over here, these are all metals. So all of these guys and these guys down here also fall into the category of metals. Because remember, if they were inserted in the periodic table, they'd definitely be on this left side. These are our metals. Okay, if they're not metals, they must be non-metals. And so the other side of the periodic table are our non-metals. And so that does include hydrogen. Hydrogen's special, and we'll talk in class why. But all of the other stuff on this other side, these are all of our fabulous nonmetals. And if you're paying attention, you'll notice I kind of skipped a few in the middle, the ones that are right around that zigzag line. This is the break point between being a metal and being a nonmetal, and these elements have properties that are in between metals and nonmetals, and so we call these our metalloids. Okay, so we have metals on the left, nonmetals on the right, and then elements on both sides of the stair-step line. Those are going to be our metalloids. Notice that boron is a metalloid, but aluminum, based on its behavior, acts as a metal. So that's the only kind of deviation from either side of the stair-step line is a metalloid. And I want to emphasize again that hydrogen acts as a non-metal. We will talk about why in class, but it's the only one that's really super far out of bounds. Okay, so we have these big three basic categories. And then from here, there's so many metals. We've actually subdivided the metals into, I'll say, a little more nuance for our metals. The metals in the center of the periodic table, so the ones whose outer electrons are going into the d orbitals, all have similar behavior that's a bit different from the rest of the metals. And so we call those our transition metals. Next, the metals that are to the right of the transition metals and kind of under the stair step, since they come after, as you move left to right on the periodic table, from the transition metals, we call these our post-transition metals. And then we've got just two more that I want to kind of bring attention to, and these are the ones at the bottom of the periodic table. They're actually already labeled on the periodic table, but these are our lanthanides and our actinides, and you'll notice they're written as lanthanoids and actinoids. That is kind of more of a over-the-pond European way of talking about them. But these are our lanthanides and our actinides. And interestingly, like each of those rows actually has some similar characteristics. And so we kind of group those together. Okay, one last thing you guys have to know, and that is the names for some of the families. The ones that we come across really commonly, we often want to talk about all the elements in a single column or in a single group with, you know, one fell swoop. And so we have names, and we're going to talk about names for 4 of these groups or families. Starting on the left, we have group 1. Group 1, lithium, sodium, potassium, rubidium, cesium. I know hydrogen's at the top, but it really behaves more as a nonmetal, so we're going to ignore him for a minute. You've got this column right here, group 1. These are your alkali metals. We'll play with some of these in class so you can kind of get to know them, but they have some similar properties. They're all relatively soft as metals go. You can actually cut them with a spatula or with a blunt knife. And when you toss them in water, they have a very characteristic response, which I'm going to show you, so hold that thought. But we say that they're very reactive because they do react readily with water. So that's group 1, our alkali metals. Group 2 are our alkaline earth metals. Again, alkaline earth metals exhibit similar properties, both physical and chemical. They're a bit harder than the group 1 metals, but they will still react with water, although less vigorously. And again, we're going to take a look at those in class. So group 2, when we want to refer to those as kind of as a category, those are our alkaline earth metals. We're now going to jump to the other side of the periodic table. When we get to group 17, these are our halogens. We'll talk about halogens all the time. They are also very reactive, and we're going to talk about why in class, but they tend to do a lot of different chemical reactions. And they have, again, some very similar patterns to the way that they're going to behave. So when I want to talk about fluorine, chlorine, bromine, iodine, all of those as a whole, those are our halogens. The last ones you guys need to know a name for is group 18, our noble gases. Noble gases are of interest because they don't react. They're actually incredibly unreactive as chemicals go. It's really hard to make them undergo a chemical change. They just hang out as themselves. Hi, I'm neon. Unless you work really, really hard to make them do some chemistry. And so noble gases are a group that, again, because they have a consistent set of behaviors, we're going to talk about them quite a bit. So that's what we got, guys. We've got periods running horizontally. We've got groups running vertically. We have metals on the left side of the periodic table, non-metals on the right side. metalloids in between them down the zigzag line. We can talk about metals in smaller subsets as our transition metals, our post-transition metals, and our lanthanides and our actinides. And then lastly, we have some groups that you do need to know the name of: your alkali metals, alkaline earth metals, halogens, and noble gases.